Okay, let f of x equal x times the square root of 1 minus 3x. Find all horizontal tangent lines. Okay. As usual, I'll give you a couple of minutes to work on this. Right? Make sure you sketch out, make sure you understand what you're actually doing. Right? Obviously, a derivative is going to be important. You need to take the derivative, but make sure you ask yourself, why am I taking the derivative? Why do I need to do that? I'm going to give you 3 minutes because there is a little bit of algebra here. But if you don't finish, it's okay, right? I don't expect everyone to finish in 3 minutes. Okay, how do we start the problem? Who wants to just very quickly sketch out what we do? No details, just kind of the sketch. Mariam. I was going to say you're on your phone, but I think that's your calculator.
It's a calculator. So basically the first thing I did was product. Well, I made the root 1 minus 3x.
Okay, you took the derivative.
Yeah.
Okay, good. So I have f prime of x. And what rules are we using? What are the main rules?
Product rule, and then you have to use a chain rule for part of it.
Okay, good. So product rule for the whole thing, and then you use chain rule inside of that. Okay, once you have the derivative, what do you do with it?
Set it equal to 0.
Okay, good. Set it equal to 0 because I want horizontal tangent lines. And then the last thing we do I actually want the equation of the tangent line, so just make sure to
Oh,
put x back
okay.
into the original function. Yeah. So
Okay.
get y equals. Okay. So now that everyone is kind of on the same page, we know where we're going. Let's actually do that. Okay. First, find f prime of x. Okay. So like Miriam said, we're going to use product rule, and then within that, there's a chain rule. And she also said she wrote 1 minus 3x. It's to the 1/2 instead of using a square root, right? So she can use power rule, right? So it's a little bit easier. Okay. So in gray, let me write out the original function. So it's going to be x times 1 minus 3x to the 1/2. And now let's get the derivative. Okay, so product rule tells us, right, f prime g plus fg prime. So f prime g plus f g prime. And now g prime, this is now where we use chain rule. That's 1/2 1 minus 3x to the negative 1/2 times -3 by chain rule. Okay. Now, just to clean up the coefficients a little bit, so that means our derivative is 1 minus 3x to the 1/2. And here I get minus 3/2x, 1 minus 3x to the negative 1/2. So I'm just cleaning up the coefficients and making it look a little bit neater. I haven't really simplified, I've just kind of made it look neater. Now I set the derivative equal to 0 and solve for x. Okay, so in fact, I'm going to save a little bit of room. Just going to reverse those two lines. Actually, we usually like to put the 0 on the right side. Okay. Now algebra. Usually I skip over this, but I've learned my lesson over the years. How do you solve this? What would be your first step in solving this algebraically? Now, there are multiple ways you can go about this. Some ways are better than others. What would you do? Take out the common exponent, factor out an exponent. Okay. Factor out 1 minus 3x to the 1/2. Would you factor out what would you actually factor out? Yeah, to the negative 1/2. You always factor out the least of the exponents. Now, in this particular case, I don't really need to factor out. Now, if I asked you simplify this expression, yes, you would factor that out. But because I have an equation, I actually have a bit more leeway. What I can actually do is I can multiply both sides by something. What can I multiply both sides by to absolutely get rid of all ugly exponents? Right, so I'm not simplifying the left-hand side, right? I'm actually going to multiply both sides by 1 minus 3x to the positive 1/2, not negative 1/2. Do we see why that's going to be useful? Because when this gets multiplied inside, what's going to happen? This thing will cancel out, right? Because the 1/2 and negative 1/2 cancels. And then these two things combine and give me a 1. Okay, so let's do that. So I'm multiplying both sides by 1 minus 3x to the 1/2. And again, like I said, this multiplication distributes over addition. So I get here 1 minus 3x now to the 1/2 plus 1/2. So obviously just to the 1 power. And I still have minus 3/2 x. And then I have 1 minus 3x to the negative 1/2 plus 1/2. So that's to the 0 power. But we know anything to the 0 is just 1. So that kind of gets canceled. That goes away. And on the right-hand side, I just have equals 0. So see how much easier that is? Look, I can even fit it before the page break. And now we combine everything. So if I combine everything, I get 1 minus 9/2 x equals 0. Is that 9/2? 6/2 Minus 3/2 is good. And then we solve and we get x equals 2/9. So make sure you can kind of do that algebra, right? You don't have to simplify the left-hand side. You can, because I have an equation, I have a bit more freedom in what I can do, right? Okay, just first of all, just as a quick check, is x equals 2/9 in domain of the original function? And we'll see that the answer is actually yes. If you just scroll up to what the original function is, yes, x equals 2/9 is perfectly fine for that function. Okay, now the question was find all the horizontal tangent lines. So let's just actually answer that question. So that's going to be y equals f of 2/9, right? It's just whatever the y value is. So this was x square root 1 minus 3x. And that's going to be evaluated at x equals 2/9. So whatever this happens to be. So what do we get? We get 2/9 square root 1 minus 2/3. So that's 1/3. So we get 2/9 root 3. Because you've never seen this notation before, this vertical bar, when you write a vertical bar after an expression with x equals, that means evaluate this expression at that x value. So it's a nice notation. It's a good way of keeping track of the expression and the x value at the same time. Okay, questions about this problem? Any questions? The derivative, why we're doing it, setting equals to 0, any part of the algebra, the final answer. What do we got? Thoughts?
I have a question.
Yes, Harsh.
So I know you used chain rule in the last part of the product.
Okay, so we're scrolling back
Like-
up to getting the derivative, right?
Yeah, it's like 1/2 and then times 1 minus 3x to like the negative 1/2 power.
Right, that's this line right here. So
Yeah.
Hirsch, you're asking about this line. Okay, so what's exactly your question?
And then like would you have to like simplify the specific chain rule like to like so like
Did I ever simplify in this question?
No, like so you the chain rule. So like
Right.
and
We
I
use the
think like,
chain
you-
rule right here.
and then, yeah, and like before that you had a square root.
Right.
So like could you like simplify that to like 1 over like 2 times the square root of x?
Well,
Like I know like that's like
not square root of x, but I mean, I could write this as 1/2 square root 1 minus 3x, sure.
So is that the same thing essentially?
Yeah, that's what negative 1/2 exponent means.
But then like for the
1
like
over square root.
but then for this problem like you kind of had to like you kind of like didn't simplify it further because like you wanted to
I didn't simplify this further because I didn't care. I just wanted to set this equal to 0 and solve that by any means. And I like looking at it in terms of exponents. I always like exponents because I can just think multiply by the smallest exponent and that will kind of make everything.
Oh, okay.
I mean, so there are multiple ways you could have gone about this. If you want to write it as square roots and deal with that, that's perfectly fine. I just chose not to. 2 square root 3 over 27, that's the same thing as what I've written.